Here's how to create a function with inputs in Snap and in processing. Let's start with making a function in Snap, and we'll start with no input, just to keep everything really simple. So making a function in Snap looks like make a block. Blocks are the same things as functions. And we're going to make it a command block, because it's just going to do something, it's not going to output anything. And we will call it draw square. We'll put it in the pen category since it's going to draw something. So, alright. So now we have to build out the function definition, which is how do you draw a square? And we'll do that by using existing functions in Snap to build up a square. So we'll start with putting the pen down so we can actually draw something. We're going to want pen up to stop drawing so we don't get these lines between our squares. And we know that to draw a square, we're going to do some moving, we're going to do some turning, and then we're going to want to repeat that. So let's do a repeat for move 10 steps, turn 90 degrees, and then pen up. So that looks good. Let's test that function. So now we have it, we're going to run it, and we're drawing a square. Just a little small square, but that's what we wanted, so it looks good. Let's do the same thing in processing. So to create a function definition in processing, we don't have a make a block button. We're doing everything with text. And that's what this looks like. So the void indicates that it's essentially a command block or a command function. It's just going to do something, it's not going to output anything. The parentheses indicates that it's a function, but it has no inputs. We're not passing anything into it right now. And then this is equivalent to this empty area to write a function definition. So in processing, we can also make use of existing functions, but in this case, we don't really have any move 10 turn commands in the same way that Snap does, but we actually have a rectangle function, so we'll use that one. And let's draw one just start in that location, and then we'll draw one that is 50 by 50. And notice it's become a square, not a rectangle, because the width is the same as the height. So that's good. If we run this, nothing's going to happen because we haven't actually called the function. So let's actually call that. So now that we've defined a function, we have to use processing in active mode, which means that we can't just write code at this highest level here. We have to put everything inside of a function. So let's put setup in. And we'll make our screen a little bigger so we can see what's going on. And then we will call the draw square function. Notice no inputs, empty parentheses, looks good. That's the equivalent of kind of clicking on that block. There we go. So draws a square, just like this one draws a square. But that square is the same every single time, and we might actually want to be able to change the square dynamically while still using our higher level draw square function or block. So let's do that in Snap, and then we'll do it in processing. So if I want some inputs, let's say we're going to draw a square at a different location to start with. I'm going to add a little text that says @ to make it really clear what I'm doing. And then I'm going to add some input names, and I'll do an X and a Y for the location. So X, and then Y, draw a square at XY. So if I do apply, you'll notice that we get two little empty boxes. Those are slots to put the inputs. We still have to actually use this X and Y in some way in our function. And because we want to draw a square at that location, let's use an absolute move command and have our pen go to X00, XY, and then put in the actual locations like so. And we're doing it before we put the pen down because then we won't get this funny line jumping to our square. So there we go. So now we have a draw square at, and we could just put in some coordinates and see what that looks like. So here we've got a little off the screen. We could draw a square at 20, 30. Of course, you notice it's going to be different than the processing canvas, which starts in the top left corner. Snap 0, 0 is in the center. But just, you know, quirks of our different systems we're working in. So great, we have a draw square at command. Let's do that in processing. So in this case, we don't have a way of kind of labeling the text as a sentence in the same way as we do in Snap, but we'll call it draw square at because that makes it a little bit more clear what's going on. We want to, just as we did in Snap, we added these two inputs. Again, in processing, this is all going to be text, and we're going to say that the coordinates are going to be integers. So we're going to say int x, int y. And that does the exact same thing as creating these variables here. It creates these temporary variables that are going to exist inside of this function and allow us to pass data in. You'll also notice that we've got these underlines here. It's saying draw square does not exist. We have to kind of apply that change to this. And now we get this other error that says it expects parameters like draw square at int, comma, int. So it's basically saying we've got these two empty slots here, but we haven't put anything in them. So we have to pass something in to be used in the function if we've told it that it's expecting those two inputs. So let's draw it at 2050. And then we have to actually use these variables to pass through the 2050 or whatever inputs we put in to where the rectangle is drawn. That's super straightforward. We can just put them here. So there we go. Let's try that. Now we've got a square. It should be at 2050. We could draw a second one at 140. There we go. About what you would expect. So there we've got a function with inputs. Let's add one more input just to really make sure we've got this down. So let's do it in Snap first. Why don't we do a size? So we'll add some text to make that clear of size. And here the size is going to be the same for the width and the height. So we really only need one input. We'll do size. We could also even call this side length, something like that, but I'm just going to call it size. That's pretty clear. So I'm going to move this variable down to the move size steps. So now it'll move whatever number of steps as we put in as an input. I'll hit apply to give us that extra slot. And then let's do of size 30. It'll be a little bigger. So now it's still at the same spot where we last drew a square, but now it's a little bit bigger. And going over to processing to do that, we'll give it another input, and we'll just call that size. And now we can use that for the width and the height. Size 100, maybe of size 53. And now our two squares are of different sizes. So we still have these nice, clean functions that wrap up maybe a bunch of functionality, but they are allowed to be flexible. So you can change the numbers here and you use the function in a different way. I'm going to do one more and we'll just do this in processing now. What if we wanted to change the color? So I'm going to add another variable called of type color and have the data type be, data type is color and the name is going to be C. So what if we want this rectangle to be of a different color for the fill? So we can't do that in the rectangle command. We need to use another built-in processing function. So we'll do turn fill to C. And now we're getting this error again because we're expecting a fourth int. Colors are actually ints, but it makes it really clear to use the data type color. And so we can pass in a color, and let's just say 255, 0, 100, and then maybe here we could do 100, 20, 50. I have no idea what those colors are going to be, but let's try it. So now I've added new flexibility to my function. Now I can actually change the color, but again, I can change it at this level. I can still just have one function definition that can get as complex as I want, and it keeps everything really nice and concise. There you go.